You see we have a branch called master right here. We just have one branch, which is created by default when we create a repository. So what are the branches and why is it called master? Typical use case in a development team is you develop new features for an application or you fix bugs in existing features. And now imagine 3 developers are developing new features and 2 other developers are fixing some bugs. And each does their own code changes. Now we said it's important to commit changes often and in small chunks to the master branch, right? To the main branch in the repository. Imagine if each developer pushed their changes to the repository, what a mess that repository will be. No one would know the actual state of the repository. Are the 2 bugs fully fixed or just partially done? Are the 3 features fully implemented or are they not fully working yet? No one could tell when the repository is in a state that you can build the application and deploy it somewhere based on that current state in the repository. So the concept of branches exists in order to cleanly divide the work of different developers. Best practice is to create a branch for each feature and each bug fix. And these Git repositories also support those best practices. So if I go to branches here, I just have one branch, as you see. I can create a new branch. The naming standard for feature and bug fix branches is actually to have them prefixed with either feature, and then you have the name of the feature, for example, authentication, it's a user authentication, or if I'm fixing a bug, for example, it would be bug fix, user authentication, error, or whatever. So basically we use branches also as a description of what is happening in that branch, what code changes are in progress, is there a new feature that is developed, or what bug is getting fixed in that branch, right? So again, good for clear separation. And you have one branch per bug fix or per feature. These are the best practices. And now developer can commit its half-done or work in progress changes as often as they want without breaking other people's code. And once fully implemented and tested locally, developer can now say, my feature or my bug fix is done. I can merge it into the master branch. So everyone else can also use that. And also now the new feature can be deployed with the next release version. So each developer works with their own branch, and when done with their own changes, they merge it back to the master. Important to note here is that if the features are too big, it may take long to fully implement the feature, and it will increase the chance of conflicts when it's time to merge multiple of such features in the master. So that's why it's important also to have small features that don't take a lot of days or weeks to implement. Otherwise, developers will have to communicate and solve the merge conflicts all the time. So as a result, in the team, you always know what the current state of the master is, and you always know there are no half or in progress features or bug fixes in the master, and that it's always deployable, so to say. It's always ready for the release. So there are 2 ways to create a branch. Either we can create it in the UI, as I showed you here. Every Git repository allows you to create branch in UI. We can do that here. I can actually leave that bug fix, create branch. And note here that we created the branch based on master, right? So we have now exactly the same code copied from master and branched it into a new branch. And now we can make changes in this branch, and that will divert the branch from master, right? But we have to base it on some branch. And again, best practice is to do that from master. And now if I want to work with this branch that I created in UI, my local Git repository doesn't know that this branch was created. This means if I do git branch here, I see just one branch, right? I just see master. So my local Git repository has to know there's a new branch. So we do that by just pulling the changes from the repository. And here you see I get update, the new branch was created, and this is the name, right? So now I'm still in the master. So how do I get started working in that new branch? I do that using git checkout command. So git checkout basically lets me change the branch that I'm working in. So if I do this, you see now I have a local copy of that branch which is connected to the remote branch. And now I have switched to that branch, so every change I make now in the code will only affect this branch right here. Another way to create a new branch is something that I use most often because it's more convenient and faster, is using command line, right? So let's say I'm starting to work on a feature that will add some new functionality. Let's say I'm connecting to a new database. The first thing I need to do is go back to the master, because again, we're basing our new feature branch or our bug fix branch on the master code, right? So I'm going to check out master. And now when I have the up-to-date state of the master, I can create a new branch. And I can do that using git checkout. And here I provide the flag, the option -b. And now I can write the name of my feature branch. Let's say database connection, right? Now this feature branch doesn't exist yet. So with this option, Git will create that branch with this command and also check out to the branch. So it's going to do two things in one command. So here you see the branch was created and I automatically switched to that branch. This is way faster and more efficient for me. I don't have to go back to UI and create the branch there and then pull it. I can just do it locally faster. Now, I have a branch now locally. Let's again do git branch. I have master branch. I have the bug fix that I pulled, and I have the feature branch that I just created. Now, the remote repository doesn't know about this feature branch. So if I go back and refresh, you see here I only see the two branches, right? So now we have the same thing as before. Now my local repository has the branch, but remote should know about it, right? So the bug fix branch, we pulled it from the repository. The feature branch, new branch, we have to push to remote repository so it knows about the new feature branch. So first of all, let's make some changes. Right now, it's exactly on the same state as master. So let's do something very trivial. Let's just update README just to have some change to commit. Let's just change this here, installing all the dependencies. All right. Of course, in realistic case, I would change some code that actually connects to the database, have some code changes, and then I will commit those changes. Let's say, doesn't really matter. And let's clear this up and do git status. Nothing to commit, but I have a new commit to push to the repository. So what happens if I do git push? Here you see git push alone doesn't work because, as I said, the remote repository doesn't know about the feature branch. So it says I don't have a branch where I can merge these changes from your local repository to, right? So that means we have to push the branch itself and then the changes in the branch. So we do that using this command. Git push set upstream origin feature branch. So this pushes the branch to remote repository. And now if I go back, drop down, I see the feature branch right here. Right. And one thing to remember here is that you don't have to memorize all these commands. For example, I never type out this git push set upstream because I know that when I type git push, it will give me the suggestion of the command that I can just copy, right? So you don't have to memorize these things. You don't have to memorize the pull requests and so on with the attributes, because Git gives you a lot of cheat sheet suggestions, so to say. But it's important to know the concepts. It's important to know that when you create a branch in remote repository, the local branch has to pull that change, because otherwise it doesn't know there's a new branch. And the same way, if you do some changes in the local repository, you have to let the remote know. And when you know the concepts, you can look up the commands, or you can just basically use the ones that Git suggests you. Another thing to note here is that a lot of projects, a lot of teams actually have two main branches in their projects. So they have the master branch and they have the develop branch, or dev branch, so to say. It's a very common practice. So dev branch basically represents the intermediary master, right? We said that the master should always be in a state where all the developers know this is a state that is ready for production, right? It's a tested code. It's something that is candidate for the next release, so to say. So how this works is that the teams that are developing in sprints, they create their feature branch and bug fix branches, and they merge them to develop branch. And at the end of the sprint, be a 2-week period, a 3-week period, or whatever it is, develop branch then gets merged into master, right? So they test the develop branch and all the changes that were made there, and then merge it into master. Now, what is the difference between these two practices? What is the difference between having just master branch and then having those branches constantly merged into that, or having an additional develop branch? Now, if you are doing, or if you are developing and setting up continuous integration, continuous delivery pipeline, then you should use only master branch. Because the way it works is that every change that you make to the code, meaning every time a new feature gets completed and merged into master branch, or every time a bug fix gets completed and merged into master branch, that will trigger a pipeline that will test the code and that will build the application and deploy it at least to the staging server, right? So that's continuous delivery. And for that, you need a dev branch, because you're not collecting your changes and then at the end of the sprint, merging it to master and deploying it, but rather you're deploying every single bug fix, every single feature right to staging server. That's important to understand. When you have develop branch as an intermediary to master, what happens is the developers basically collect the new features, the bug fixes, and all the different changes in dev, and then they take that big chunk of changes at the end of the sprint, merge it to master. So they have releases once every end of the sprint, right? And there are some complications with that, because dev branch can actually end up being the work in progress state, and they have to be careful and synchronize when it's time to merge develop into master and so on. So the best practice in DevOps, and if you want to do it the modern way, so to say, meaning set up the continuous integration, set up the continuous delivery the proper way, then you have to go with having master branch, and you don't need the intermediary dev branch anymore. So that should be the best practice, actually. But for DevOps engineers, it's important to know that there are teams of developers that are working this way and have dev branch. Some even have third branch, which is a staging or test branch in addition. So it's important to know that these are the practices they're working with. And if you want to move to the proper DevOps pipeline with continuous delivery, you have to move away from that and implement just one master branch and build and deliver the changes after every merge to the master branch.